start recording. Okay, fine. If we are given these 2 points and they're saying to you, find the gradient of PQ, find the gradient of PQ. So let me insert the formula for gradient to determine gradient. So the formula to determine the gradient, we know that the gradient is always change or in x over change in something. This will be your formula. The gradient of PQ will be equal to we say it's x2 minus xy, and then in the numerators we have y1, y2 minus y1. So this is the formula to calculate the gradient of a function, or the gradient. If they're saying calculate a gradient given point P and Q, how are you going to calculate the gradient? You're going to use this formula. So I will take this formula and copy it, then replace by what we have. So here our y2, I will call Q, the point Q will be my 2's, and then P will be my 1's. So y2 in this case will be f of x plus h subtract f of x all over, and then here the x that I have is just x. So the point that I have here, it's x, the value of x is x, and the value of y, the value of another x value, it's x plus h. So I plugged in my coordinates or my points. So after plugging in the coordinates, we are going to add the like terms. If you can look, we have positive x here and negative x. So positive x and negative x will cancel. So the gradient of PQ will be equal to f of x plus h minus f of x. So this is where the formula that we're going to use derives from, that f of x plus h minus f of x over h equal to the gradient. So if we are going to determine this function from first principle, you're going to utilize the formula. So let's insert our equation. It has limb. So we are saying, okay, let me clear this one. Okay. It says the limit of the function as h approaches 0. Let me fix here. and then this must be h equal to of x. This is the formula that we're going to use to determine the given function, to derive the given function from first principles. This is the formula. Whenever they say determine the derivative from first principles, always remember that you're going to use this formula, and it's always there. It's always given on your answer sheet. You always have it. There's no way you can write math without having it. It's always there. Always remember that equal to comes before the limit, not after the limit. It would be wrong if you said f of x is the limit of the function as h approaches 0, and then you put equal sign here. It will be wrong. The equal sign comes before the limit. So fine. But because we are dealing with a fraction, my advice to you would be that if you're dealing with a fraction using first principles, the first thing that you have to do is to the first thing that we're going to do, we're going to determine f of x plus h. By determining f of x plus h, simply where we see x, we're going to replace by x plus h. Where we see x, we will replace by x plus h. And then on the next step, I'm going to find the difference between f of x plus h and f of x before I can even start deriving. So here's the second step, which will be f of x plus h subtract f of x, which will be equal to, remember that our f of x plus h, we set it to be 2 over x plus h. So 2 over x plus h subtract 2 over x. Then let's simplify this. We're having a fraction, so this one will multiply this one will multiply this one, and then we'll multiply the numerators. So it will be 2 will multiply x, and then in negative 2 will multiply x plus h. And this all over x, which is multiplying x plus h. So in the numerator, we're having negative 2, that is multiplying terms inside the bracket. So we'll have negative 2 multiplying x, negative 2 multiplying h. So this is what we're going to have. We'll have 2x, which is already there, minus 2x, because it's negative 2, which is multiplying x, and minus 2h, because it's negative 2, which is multiplying positive h. So positive times negative becomes negative. So all over. And then here we're having x, which is multiplying x. It will be x squared. And then in x, which is multiplying h, then we're having xh. So let's add the like terms. We're having 2x minus 2x, meaning that they will cancel. 2x and minus 2x will cancel. So and minus 2x will cancel, so we're going to be left with minus 2h equal to minus 2h over x squared plus xh. So, okay, fine. Now that it's simplified, we are ready to derive. So we can now use this formula. I can now use this formula. We know, okay, now let's replace our f of x plus h minus f of x. Our f of x plus h minus f of x, we have already worked that out as 2h, negative 2h all over x squared plus h, x squared plus xh, all divided by h. So I want to like simplify this to avoid having too many division lines. So I'll take this h and bring it here, and then I will utilize this division side.
Okay.
So we're still continuing. Remember, we keep the limit for as long as you haven't started, you haven't arrived at your final answer. You still keep the limit. So it will be the limit of, okay, this side I will have x squared plus xh plus xh negative 2h over x squared plus xh, and then divided by h. Let me just say h over 1 because it doesn't really make a difference to write it as a fraction. So on the next step, I will change this division to multiplication. So when I change division to multiplication, the denominator becomes the numerator, and the numerator you change h over 1 to make it 1 over h.
1 over h.
So let's quickly do that. So we're going to change this to multiplication. So when it changes to multiplication, 1 will go on top and h will come down. So we'll have something like that. Now it's a straight multiplication. This one, negative 2h will multiply 1, and then x squared plus xh will multiply h.
Okay.
So let's quickly do that. So on the bottom we'll have h multiplying x squared plus xh, x squared plus xh. So if we check, we have h on top and we have h on the bottom, so this h will cancel this h. So after cancelling h by h, every time you're dealing with when you are deriving from first principles, the minute you divide or you take out h as a common factor, the next step, any term that is remaining that contains h, you drop it, you drop the limit, and then you give the final answer. Meaning that what we're going to remain with will be minus 2 over x squared. So we're going to drop this term because x carries h, and then we also drop the limit. So that's your final answer. your final answer, you'll say it's equal to minus 2 all over x squared minus 2 all over x squared. So this is your answer. You have derived from first principles. If you are going to use the rules of differentiation to derive this function, if you're going to use rules of differentiation, for example, you are given f of x equal to 2 over x, and then they're saying derive this using rules, not from first principles, but rules. Always remember that if you're having something like that, uh, if you're having a to the exponent something, a to the exponent negative n, this can also be written as 1 over can also be written as 1 over an. So if you're given something like this is in the form 1 over an. The first thing that you're going to do using rules, you will write it in this way, of which it will be a to the exponent negative n. So let's take 2 over x and write it as a to the exponent negative n. So if you are to write 2 over x as a to the exponent negative n, what will you have? It will be 2 to the 2x. It will be 2x to the exponent negative 1, because in this case you're saying uh, did you type a question in the chat box or? Could you please repeat your question, because I didn't hear anything? Oh, you exited. Okay, I wasn't even aware that you have exited the meeting. So the first thing that you're going to do is to write, if you're going to derive this function using rules of
No, I
differentiation.
can't see the screen now. I cannot see the screen. Yeah, thank you. Now I can see it.
Okay. Why are you busy exiting?
No, there was a call, then I was trying to WhatsApp that person to tell him that I'm on a meeting. So I went off from the meeting. I don't know what happened.
Okay. So if they said to you, derive this function using rules of differentiation, the first thing we're going to take 2 over x and write it as a to the exponent negative n. So 2 over x as a to the exponent negative n is equal to 2x to the exponent negative 1. So fine, let's use rules to differentiate. We know that when you're using rules, this power will come and multiply a, will multiply a, and then from the power we are going to subtract 1. So on the next step, what you're going to do is, on the next step, you will take that negative 1 to multiply 2, and then from negative 1 you subtract 1. So if you can say on your calculator, negative 1 times 2 is negative 2, right?
Yes.
Negative, negative 1 times 2 is negative 2, meaning that uh, this side you're going to be left with negative 2.
Negative 2.
And if you say minus 1 is minus 2. So you're going to have minus 2x to the exponent minus 2. So because you were given this as a positive exponent, it is always advisable to write it as a positive exponent in your final answer. This is your answer. But to write it as a positive exponent, we are going to take it back to how it was, 1 over an. So if you're going to write it as a positive exponent, it will be negative 2 over x squared. So this is when you're deriving something of this form, using rules of differentiation. And if you can check, minus 2 over x squared is the same answer that we got when we used first principles. But look at the question, what does it say? What do they want you to do? For as long as they're saying determine from first principles, the derivative from first principles, you're going to utilize this method or this formula. It should be done in this way. Unless if they're saying use rules. If they're saying use rules, then it's fine. You can just use the rules and get straight to the answer. But another thing, if you're given something like this and they say determine from first principle, my advice to you would be first use rules of differentiation. Then once you get the answer, just know that when you're going to use the limit, the answer that you got should be the same as the one that you're going to get when you're going to use the limit of the function.
Okay.
At least it will lead you to what the answer is. So, okay, fine. We can continue and do 8.2.2. So it says determine dy over dx. Determine dy over dx. Determine dy over dx. If y is equal to x squared minus 1 over x squared minus 1 over x squared all squared, all squared. So they want you to derive this using rules of differentiation. You're going to derive this using rules of differentiation. Using rules of differentiation. If you were to derive something like this, it's a binomial, a square of a binomial. My advice to you would be, before you can even start deriving, just first simplify what you're given. First, start by simplifying what you're given. So why, if we're to simplify it? We are squaring a binomial. So the first step, we're going to square the first term. We're going to square the first term. You square the first term, and then you multiply the terms inside the bracket. So you're going to multiply the terms inside the bracket, and then the answer that you get, you multiply it by 2. So inside the bracket we have x squared. Inside the bracket we're having x squared. Let me just write it as a fraction because the other term is a fraction. X squared over 1 multiplied by 1 over x squared minus 1 over multiplied by minus 1 over x squared. And then what is left for us is to square the last term, which is minus what? Okay, if we can check minus 1 over x squared, we can write it as what? We can write it as minus 1x to the exponent negative 2. Minus 1x to the exponent negative 2. And then this term will also square it. So if we can check, if we multiply these guys, okay. If we, this is straight multiplication, it will be x squared, which is multiplying negative 1. So we'll remain with negative x squared, and in the bottom we're having 1 that is multiplying x squared, meaning that we are going to be left with x squared. We're going to be left with x squared. So same basis what we do, we subtract the exponent, meaning we'll have something like this: y equal to, here we're having a power that is multiplying another power, so it will be x to the power 4, because we're having 2 that is multiplying 2, x to the power 4, and then this side plus 2 into negative x to the exponent, negative x to the exponent 2 minus 2, because at the same basis we subtract the exponents. And then in here we're having positive into negative, so we'll remain with negative. Let me just write it as x because it doesn't make any difference. X to the exponent minus 2 times 2. Minus 2 times 2 is minus 4.
Minus 4.
Minus 4. So 2 minus 2, it's how much?
0.
2 minus 2 is 0. Okay. If 2 minus 2 is 0, we know must every number that you raise to the exponent 0 is how much?
0.
No, it's not 0, it's always 1.
It's 1.
So meaning
But
that
isn't it?
here, huh? Any number that you raise to the exponent 0 is always 1, equal to 1. So we're having 2, which is multiplying negative 1, because here will remain with negative 1. So 2 times negative 1 will be minus 2. And then minus x to the exponent negative 4. Exponent negative 4. So now that it's simplified, we are ready to derive. We can now bring this guy over. So the derivative will be equal to, the derivative will be equal to 4 will come and multiply x. So 4 times x will be 4x. And then from the exponent, we are going to subtract 1.
1.
So the exponent is 4. If we subtract 1 from 4, we're left with 2. We're left with 3. And then the derivative of a constant is 0. So this one, we leave it, and then we're going to this one. We're having a negative 4, which is multiplying negative 1. Okay. No, this one must be positive. It must be positive. The reason why it must be positive, it is because when we squared it, it was negative. It was, you can see we're squaring a negative. So when you square a negative, negative times negative, it becomes positive. So we'll have 4x cubed minus, this negative 4 will come to multiply x, minus 4x to the exponent.
3.
To the exponent, no, it can't be 3 because it's minus 4 minus 1. If you say minus 4 minus 1,
Minus 4 minus 1. Minus 5.
minus 5. So this is your derivative, but remember that you were given as a positive exponent, So let's write it as a positive exponent. So if we were to write minus 4x to the exponent negative 5 as a positive exponent, what we'll have, if we were to write it as a positive exponent, we're going to have 4x to the exponent 3, 4x cubed minus 4 minus 4 over the power 5. So this is your derivative. You determine dy over the x. You determine dy over the x. dy over the x. So Proceeding to the next question, which says determine dx. Determine dx. Says determine dx. If you are given what? Do you still have this question paper? Or
I do have it.
it says determine dx. If you're given x to the power 3 subtract 1. So we're having something like this. Firstly, let's before we can start deriving. Okay, let me push this thing. I want to push this thing in such a way that it's not base. Yeah, it's not as in subscript. Okay, we are given this saying determine the x given x cube subtract 1. Firstly, before we start deriving, for as long as you haven't started deriving, you keep the dx, throughout until you are ready to derive. So let's simplify this one. If you can check x cube minus 1, it's the difference between two squares. So x cube minus 1 is the same as x minus 1 into x squared plus 1x plus 1 squared plus 1x plus 1 squared. So that's our first step. We're going to write it this way. Just because we're having 1x, we can just choose to write it as x. So if you can multiply this throughout, it will give you x cube minus 1. We call it the difference between two cubes. The difference between two cubes. So we're having x minus 1 and x minus 1, so they will cancel. This one will cancel this one. Now that it's simplified, we are ready to derive. Because now we are deriving, we are going to drop the dx. We're going to drop the dx and then give the answer. The derivative of x squared is 2x. And then what is the derivative of x? It's 1. How did we arrive at this one? As we said, x is the same as x to the power 1, right?
Yes.
So 1 comes down to multiply x, and then from the exponent we are going to subtract. From the exponent we are going to subtract 1. So it's 1 minus 1, because our exponent is 1. So from the exponent we are going to minus 1. So 1 minus 1, it gives you 0. So if you plug in 0 here, x, any number raised to the exponent 0 is 1. So x to the power 0 is 1. So 1 times 1 is 1. So that's why we say the derivative of x is equal to 1. So the derivative of a constant, is 0. So your final answer is 2x plus 1. You are done. So let's go to question 9. Question 9, let me quickly insert. Let me quickly insert that function. We have h of x equal to having h of x equal to negative x cube plus bx plus ax squared plus what? Plus bx. We're having this equation, this function, and also the other thing that we are given is gx, the graph of gx, which equal to negative 12x. And then they are saying to us p and q are what? Pretty. They're saying p and q are what? Are you still there? Huh?
Yes. Yes.
They're saying p and q are? Why are you quiet, Kant? Or you don't have the question paper with you? Because what I'm asking you, you
No,
have it with you.
I didn't do the printout. It's still on WhatsApp. I'm using it on WhatsApp.
It says P and Q are the turning point of the graph of H, passes through the origin. It says the graph of H passes through the origin. The graph of H passes through the origin. Okay, fine. This is what we have. And then the first question says, show that A equal to 3. That's the first question. Show that A equal to 3 over 2. Show that A equal to 3 over 2. This is our first question. And B equal to 6. We are going to show that A equal to 3 over 2 and B equal to 6.
Yes.
Okay, let me expand this one so that it can be clearly visible. Show that A equal to 3 over 2 and B equal to 6. So let's look at what we're given. We're given the graph h of x equal to negative x cube plus ax squared plus bx. And the other thing that we're given is the graph of g of x, which equal to negative 12x. And they are telling us that P and Q are the turning points of H. We're having the coordinates of Q, but of P we don't have, are the turning points of H. The graph of H says that, okay, I wrote this thing twice. The graph of H passes through the origin.
The origin.
When they're saying that the graph passes through the origin, it means that if you were to draw this graph, the value of maybe it will intersect the y-axis and the x-axis at 0. If you were to draw this, it will intersect the y-axis and the x-axis at 0. So let's show that a equal to 3 over 2 and b equal to, meaning that we are going to calculate these two variables. So they told us P and Q are the turning points. Remember that when you are dealing with a cubic function and then you are calculating the turning point of that cubic function, what do? The first thing that you do is to find the derivative, the h prime of that function. So the derivative of this function, negative x cubed plus ax squared, will be minus 3x squared minus 3x squared plus 2ax plus b. This is the derivative of this function, the derivative of the function. So if or if x equal to 2, then the value of y at this point in the derivative, if x in the derivative is equal to 2, the value of y is 0. Because whenever we're calculating the turning points of a cubic function, we derive, and then after, to find the value of x, we equate the derivative by 0. So in the next step, I will replace x by 2 and then equate it to 0. I'll replace x by 2 and equate it to 0. So but don't forget that this is equal to CU. This guy here is equal to 0. So if you were to use a calculator to determine that, we're having 2 squared. I got 2 squared, which is 4. 4 times negative 3 is how much? 4 times negative 3 is negative 12. Meaning that here we're going, it's
negative 12.
It's negative 12. So we have negative 12, and then we have 2 times 2.
It's 4.
2 times 2 is 4. So 4a plus b equal to 0. It's equal to 0. So let's take negative 12 plus 4a to the right hand side to remain with b. So if we're to take the negative 12 plus 4a to the right hand side, this side will remain with b, which is equal to 12 crosses the equal sign. Positive. It was negative, it becomes positive, and then in 4a it was positive, it crosses the equal sign, becomes negative. So we're going to have b equal to negative 4a. So you can say this is what? Your equation 1. This is your equation 1. So let's go and get our equation 2. So our equation 2, we are going to take this x value, which is 2, and substitute it into the original equation, not in the derivative, but in the original. Okay. Because after getting the value of x from the derivative, because when you calculate the coordinates of the turning points of a cubic graph, the first thing you derive the function, equate it by 0, find the value of x. After getting that value of x, you plug it into the original to find its corresponding y value. So we are going to plug 2 into the original equation to find the corresponding y value. But we already know what is the corresponding y value. It's given. The corresponding y value in this case is 10. So the next step, let me expand this so that it can be, at least you can see it from your phone.
Yes.
Okay, let me reduce it a little bit. So this guy, I will equate it with 10. I will equate this thing with 10. It's equal to 10 because it's the corresponding y value. So if I say negative 2 cube, it's equal to how much?
Negative 2 cube.
Yes, negative 2. It gives me negative 8, which will have negative 8. And then 2 squared is 4. 4 times a is 4a plus 4a.
Plus
B times 2, it's 2b plus
2b.
2b equal to 10. Let's make b the subject. So I will take this guy's negative 8 plus 4a to the right hand side. So that I can remain with b. So 2b will be equal to 10 plus 8 minus 4a. So let's add the like terms. B, we're having
18
18
plus 4a
minus 4a. 18 minus 4a. Let's divide both sides with 2 so that we can be left with only b. So if we divide both sides with 2, we'll have b equal to 9 divided by 2. 18 divided by 2.
It's 9.
9. And then 4a divided by 2.
2.
It's 2a.
2a.
It's 2a. So this one, you can call it your second equation. So if we can check, we're having b here, meaning that these two, we can equate them. So let's equate 12. Let's equate 12 minus 4a with 9 minus 2a. Group the like terms. I will take terms that contains a to the left and then in the constant to the right. So I will have minus 4a plus 2a. Minus 4a plus 2a is equal to 9 minus 12. So let's add the like terms. We're having minus 4a plus 2a, which is how much?
Minus 4.
Minus 4 plus 2.
Minus 2.
It's minus 2.
Minus 2a.
Minus 2a, which equal to 9 minus 12.
Minus 3.
Minus 3. So let's divide both sides with minus 2 so that we can be left with a. Okay. We're going to divide both sides with negative 2. So negative 2a divided by negative 2a divided by 2 it's negative 2a divided by negative 2.
-1.
It can be negative 1, which equal to negative 3. Negative 3 over negative 2. Please do what you see on the screen. Negative 2 over negative 2 is how much?
It's -1.
Impossible to be negative.
-2 or -2 by -2.
Yes.
Sorry, I did -2 by +2.
No, where do you get the positive? Because I've been saying negative, and
Positive
even here it's positive 1. Okay. So we're going to be left with a equal to, and then in negative 3 over negative 2 is assembly. Negative cancels negative, and then it will only remain with the positive. So a equal to 3 over 2.
over 2.
If you go to the question, it said show that a equal to 3 over 2 and b equal to 6. So now that we have the value of a and we know what b is equal to, let's take this. I want to copy this thing down. We have the value of a. So now let's determine the value of b. We are going to replace 3 over 2 where we see a. So
Okay.
b equal to
3
b
over
equal b equal to
9 -2.
b equal to 9 minus 2 into
3 over 2.
9 minus 2 into 3 over 2. So if you check, 2 and 2 will cancel. 2 and 2 will cancel. So if 2 and 2 cancels,
Left with
b equal to 9 minus 3. So what is 9 minus 3?
6.
Which is 6. So you've answered your question. Show that a equal to 3 over 2 and b equal to 6. So you've answered the question, and then now you're ready to proceed to the next question. So okay, fine. Since we have shown that a equal to 3 over 2 and b equal to 6, we can take these values that we got and plug them into the formula or into the equation. So let's plug them into the equation. The values that we got, plug them into the equation. We know that a, now we know the value of a. Now that we know the value of a, we can write it. It's 3 over
2.
3 over 2 squared plus our b is 6. So it will be minus x cubed plus 3 over 2x squared plus 6. So I wanted to show you something. When they say the graph passes through the origin, meaning that the graph will intersect the x-axis and the y-axis at 0, at the point 0. So if I were to draw this graph, If I were to draw this graph, okay, you will quickly see the graph how it will look like. This is not supposed to be the graph. This is a parabola and it's a cubic function. This is how the graph would look like. If you can check, it's passing it is intersecting the y-axis and the x-axis at 0. This point here will be 0.
Okay.
Let me just add the points. So this is how the graph is supposed to look like. If they said to draw it, if you were to draw this graph, it would look like this one. So okay, fine, let's continue to the next question. It says calculate the average gradient of h between P and Q if it is given that x equal to -1 at P. If x is equal to -1 at P, the first thing we can do is to find the corresponding y value. So we're going to find the corresponding y value before we can find the average gradient. So let's say, okay, let me first write down the question. It says calculate the average gradient h between P and Q if it is given that x equal to -1. It's given that x equal to -1. So we are given that x equal to -1 at P. The first thing we're going to do is to find the corresponding y value when x is -1. corresponding y value. So it's negative into negative 1 cube negative into negative 1 cube will give me positive 1, and then in negative 1 squared it's 1 times 3 over 2, which will have plus 3 over 2. Are you still with me? 3 over 2.
Yes, sir.
6 times negative 1 is minus 6. So let's quickly add these things. 1 plus 3 over 2 plus, minus 6 is minus 7 over 2. It's minus 7 over 2. So the answer will be minus 7 over 2. The corresponding y value is minus 7 over 2. So P it has the coordinates of P is negative 1 and negative 7 over 2. So the coordinates of Q we are already given, which is, let me just copy them down somewhere where we'll be able to see them. So let's find the gradient. Okay, let me remove this graph. Let me delete this graph. Okay, let's calculate the gradient. Insert the formula for gradient. This is the formula to calculate the gradient. So we have negative, we're having y2 y2 minus y1 over minus x1. So okay, let's replace with what we have. We're having the value of P and Q, like the coordinates of P and Q. So this side, we're having the value of y to be negative 7 over 2. Negative 7 over 2 minus the other y value is 10 all over minus 1 minus 2. So minus 7 over 2 minus 10 is equal to minus 27. Minus 7 over 2 minus 10 is equal to minus 27 over 2. minus 27 over 2 divided by minus 1 minus 2. Minus 1 minus 2 is minus 3 divided by minus 3. To write it as a fraction, over 1. So let's turn this division to multiplication. Minus 27 over 2 multiplied by minus 1 over 3.
Sorry, how did you get 27? Is it not 17?
What?
27.
If you say minus 7 over 2 minus 10, what does it give you?
Minus 7 over
Minus 7 over 2, like this part. If you do only this part,
minus 10.
yes, the part that I've highlighted in red.
Yeah, it's minus 27 over 2.
That's where it comes from. So from here,
Okay.
minus 3, this minus 3, it comes from minus 1 minus 2.
Yes, that one I understand.
Okay, so it's direct multiplication. Minus 27 times minus 1, it will give us positive 27. So 2 times 3 is 6. So we'll have positive 27 over 6. Of which you can simplify to be 9 over 2. Which will be 9. So that is the average gradient of the graph between P and Q, given that x equal to negative 1. So the first thing that you do, because you only have the value of x, what you do, you take that given x value, plug it into the original equation to find the corresponding y value. Then from there, you use the formula to calculate the gradient and plug in your coordinates. So going to the next, it says, show that the concavity over there of H changes at, show that the concavity of H changes at x equal to 1 over 2. Show that the concavity of H changes at x equal to 1 over 2. When they're saying the concavity, when they're saying show that the concavity, we're having the formula. Let me just write it down. F h of x equal to negative x cube negative x cube plus 3 over 2 a over 2 x. So they're saying determine the concavity. When you're determining the concavity of a function, you're going to find the derivative of the derivative, meaning that the first step you're going to derive this function. After deriving it, you derive it for the second time, and then you take the second derivative, you equate it to 0. So let's take this function and derive it. If we're to derive this function that we have, we'll have h prime x equal to negative 3x 3x squared, and then in 2 times 3 over 2 plus 3 plus 3x plus 6. That's the first step. So the second step, we're going to derive this one, the derivative. So let's find the derivative of the derivative. H double prime x equal to minus 6x plus 3. Minus 6x plus 3. So next step, we're going to take this one and equate it by 0. So minus 6x plus 3 is equal to 0. Now we're solving for
0.
x. So let's take this one across. So minus 6x will be equal to, it was positive 3, what? Minus 3. So next step, we're going to divide both sides by minus 6 so that we can have the value of x. Dividing by minus 6. Dividing by minus 6. So minus 6 and minus 6 will cancel. 6 minus 6 will cancel. Negative and negative will cancel. So 3 over 6. X will be equal to 3 over 6. X 3 over 6. 3 over 6. So if we simplify 3 over 6, 3 goes into 6 2 times, and then in 3 into 3, it goes 1. So 3 over 6 is the same as x equal to 1 over 2, because 3 into 6, it goes 2 times, and then 3 into 3, it goes once.
1.
So it's x equal to 1 over 2. So you have shown that the concavity of h changes at x equal to 1 over 2. It is either they will say show that the concavity, or they will say determine the point of inflection. If they're saying to you determine the point of inflection. Let's know that we're dealing with the derivative of the derivative, point of intersection of inflection or concavity. Okay, next question. The next question that we're given here, it says, explain significance of the change in the question that we did in this question with respect to age. So simple. The answer you are given already. You were showing that the concavity of A changes at x equal to 1 over 2. So you can simply say this graph, this given graph, changes from positive to negative at x equal to 1 over 2. Okay, let me redraw the graph. Let me redraw this graph. I want to quickly redraw the graph. I may quickly redraw the graph and add all vital points to it. Okay, I want to draw this graph here.
Okay.
It's taking time to draw the graph. I don't know why. Okay. Doing your hands. Okay, let me just switch my screen because this thing is wasting my time. To where the graph is. Do you see the graph?
Yes.
Okay, let's try to locate the point x equal to 1 over 2. It should be somewhere here. So this point is somewhere here. So at this point, it is when the graph changes from increasing to decreasing. It changes from positive to negative.
Okay.
So when they say to you, explain the significance of the change in question 9.3 with respect to age, you're simply going to tell them that the, the, the graph at this point, it changes. It's like it changing its shape. If you can check, we have two parabola. One is smiling, one is frowning. So the graph at this point is starting to change, going down. So let's go to the last question of question 9. The last question. It says determine the value of x given what? We are going to determine the value of x. Determine the value of x. Value of x given x is greater than something. Given x is less than 0. At which the tangent h parallel g. Determine the value of x given x is less than 0, at which the tangent to h is parallel. So if you remember, on the statement that we had, we had that g of x is equal to something. they told us that g of x is equal to negative 12x. It's a straight line graph. It's a straight line graph, meaning that the gradient of g will be negative 12. The gradient of g will be negative 12.
Negative 12.
So we know that the gradient of g equal to negative 12. The gradient of g is equal to negative 12. And then they say this graph, which the tangent to h is parallel to g. So if we're having two lines which are parallel to each other, it means that their gradients are also equal. So the gradient of the tangent will also be equal to negative 12. So this is to calculate the gradient. I told you that when you derive a function, you're simply calculating the tangent. You're simply calculating the gradient of that function. The gradient of this function will be equal to negative 12. Let's solve for x. It's a parabola, if you can check. It's 3x squared plus 3x plus 6. Okay, let's take minus 12 across. I have minus 3x minus 3x squared to 0. So 6 plus 12, it's 18. 6 plus 12 is 18. We add like terms. We'll have minus 3x squared plus 3x equal to 0. So we can, on the next step, we can simplify by dividing the whole thing by negative 3. So if we divide negative 3 by negative 3, we'll remain with 1. And then if we divide 3 by negative 3, we'll remain with negative 1. And then if we divide 18 by 3, 18 by negative 3, which will be minus 6 equal to 0. So x squared minus x minus 6 is equal to 0. We can try to find the factors. But the factors of 6, it's 6 and 1, right?
In 1, 3 and 2.
It's 6 and 1 and also 3 and 2. So if we say minus 3 plus 2, it's how much? The factors of x and x is x. The factors of x squared is x. Huh?
Minus 3 plus 2 is minus 1.
Okay, meaning that we're going to use 3 and 2. So we have x minus 3 into x plus 2.
Plus
2. And then x equal to something. X equal to 3 or x equal to negative 2.
negative 2.
Okay, let's go back to the question. It said determine the value of x given x is less than 0. If x is less than 0, meaning that we're going to focus only on the x value that is less than 0, which is -2. So in your final answer, you'll say x should not be equal to 3, but x equal to -2. You scrub this one out because 3 is greater than 0. It's not less than 0. Okay. Okay, let's proceed to the next question at hand.
Okay.
So I'm going to switch my screen to something because this one, it's a diagram. It's a diagram, so okay. I take it that you can see.
Yes.
Okay. Okay, we're going to solve this one. It says, okay, let me expand. It says a rain gorge. A rain gorge is in the shape of a cone. Water flows into the gorge. The height of the water is 8 centimeters. The angle between the cone edge and the radius is 60 degrees, as shown in the diagram below. So your first question says, determine R in terms of age. Let me also increase this ones. Determine R in terms of age. Leave your answer in set form. When they say leave your answer in set form, it means that your answer should contain a square root or a root sign.
Okay.
So, okay, fine. We're having, if you can check this thing, it's a right angled triangle. It's a right angle triangle. So in a right angle triangle, we can use SOHCAHTOA. So we know that sine is equal to opposite over hypotenuse. Okay, let me just say sine A equal to opposite over hypotenuse. I mean, cos A is equal to adjacent over hypotenuse. And then in tan A called adjacent, opposite of adjacent. Adjacent. So the angle that we are given, it's here. So when we're looking at this angle, which we are given, which is 60 degrees, okay, let me just take 60 degrees out.
Okay.
I want to also take this 3 above. Okay, can bring it back. When we are looking at this angle, this side, R will be our adjacent, right? R will be our adjacent, and this edge, the height, will be the opposite side because it's opposite the angle that we are given. So this is the adjacent, this is the opposite. It is the adjacent, it is the opposite. So adjacent, opposite, adjacent, opposite, adjacent, opposite is cos. Okay, let's take cos of an angle. No, adjacent and opposite is tan, not cos. Tan of angle 60 degrees. Tan 60 degrees is equal to adjacent. Our adjacent side is R. The opposite side is H. 60 is a special angle. 60 degrees is a special angle. So you can use the Pythagoras triangle to determine the value of tan 60. So from Pythagoras triangle, tan 60, it's how much?
Tan 60.
Tan 60 is root 3. Over H.
It's root 3.
Yes, tan 60 is root 3. Pythagoras triangle or a right angle triangle. Trying to find a way to draw this triangle.
Okay.
Okay, here it is. Triangle is something like this. We are having something like this as the triangle. It's a right angle triangle. It is a right angle triangle. So this angle will be 60. This angle will be 30. Okay. Let me take this angle down. Now this one is 60 degrees. From the sum of angles in the triangle, other angle will be 90 minus 60. So the angle here, it's 90 minus 60, which is 30. So that when you add them together, they have to give you 180 degrees. So if we are looking at this angle 30 degrees, this side will be the opposite side, and this one will be the hypotenuse, and then this one will be the adjacent. So if you were to determine sine 30 degrees, sine 30 degrees is equal to 1 over 2. Sine 30 degrees is equal to, the side is 1
over 2.
the hypotenuse side is 2. So let's determine the side that is missing. So if we were to determine the side that is missing, because we have 1 on the side, we have 2, let's determine the missing side. We'll say 2 squared from the theorem of Pythagoras. 2 squared equal to the missing side, which I will call x, is equal to x squared plus 1 squared. Plus 1 squared. 1 squared is the same as 1, so okay. 1 squared. So because we are looking for x, the missing side. We are looking for x, the missing side. So we'll take positive 1 squared across. So if we take x squared across, we'll have, okay, 2 squared is 4. 2 squared is 4 is equal to, okay, we are taking 1 across. 4 minus 1 is equal to x squared.
Good.
So 4 minus 1 is how much?
It's 3.
So 3 equal to x squared. Equal to x squared. Three is equal to x squared. So when the value of x, we divide, we take square root both sides. So square and square root will cancel. We'll be left with x, and then in this side we'll be left with the root of 3. So the missing side is root 3. The missing side is root 3. So let's say determine the tan of this angle. And when we are looking at this angle, this is the adjacent side, and this one becomes the opposite side. So tan of 60 degrees will be equal to root 3 over 1, which is simply root 3. So this is where it comes from. And that thing is simple. You can simply do it on your calculator. It will take you straight to the answer. So tan 60 is equal to root 3, which is equal to r over 8. So cross multiplication. Let me write it in this one as a fraction. Or 3 over 1. So cross multiplication. H multiplies root 3 and then 1 multiplies r. So I'll have h root 3 is h root 3 is equal to r. So what was the question saying? Determine r in terms of h. Leave your answer in that form. So I want to check something. Adjacent. The adjacent side is this one. The opposite is this one. So r over h. Adjacent over opposite is equal to. Looking at this angle. This is our adjacent side. Oh, I see. It's supposed to be h over r, not r over h, because it's opposite over adjacent, not adjacent over opposite.
Okay.
So again, cross multiplication. R multiplies root 3. So r will multiply root 3 and then h will multiply 1. But we are looking for r. So in the next step, we will divide both sides by r.
By R.
Is no, by root 3.
Okay.
So if we divide the side by root 3, divide by root 3, and then also h divided by root 3. So root 3 will cancel root 3. So h, no, r equal to h over root 3. So there you're done.
Okay.
H equal to r equal to h over root 3, or h over root 3 equal to h equal to r. So the other question says determine the derivative of the volume of water with respect to h when h is equal to 9 centimeters. If h is 9 centimeters, determine the derivative of the volume. So this is the formula we're going to use. The volume of a cone is equal to 1 over 3 pi r squared times h. So h in this case, or r in this case, is equal to h over root 3. So let me just copy the formula for for volume. Controls. Formula for volume. So we know the value of R, we know the value of H. So the volume with respect to H the volume is equal to 1 over 3 1 over 3 pi R squared. Times height, but we know what R is. We've determined it. So R is H over what? R is H over what? Eh?
H over root 3.
So H over root 3 squared times the height multiplied by the height. Bear in mind that now we're dealing with this question.
Yes.
Okay. So we're going to have 1 over 3 1 over 3 pi 1 over 3 pi into H squared H squared over 3, because here we're squaring H over root 3, so
3.
square and the square and the square root will cancel, so H squared over 3 multiplied by 9 multiplied by H. So this H is multiplying H squared. H is multiplying H squared. So 1 over 3 pi H squared is multiplying H. So we'll have H cube.
Yes.
Squared is multiplying H, we'll have H cube over 3.
3.
H cube over 3. So okay, now we can replace H by 9. We can replace H by 9 because we're given that H is equal to 9. Over 3 pi H cube over 9, or 9 cube over
9
9
cube over
over 3.
3.
It's 243. Is it?
Let me try with my C calculator.
or maybe
over 3. Yeah, 243.
okay, fine. Before we replace h by 9, let's start and let's first derive, and then we'll replace it after deriving. So 3 will come down to multiply. 3 will come down to multiply h cube over 3. So we'll have 1 over 3 over 3 pi 3, which will be multiplying h cube over 3. And then remember that from the exponent we always subtract 1. This is the derivative dv. We can simply say v prime h, because we are deriving with respect to h. So 3 and 3 will cancel. This 3 will cancel this 3, and then we'll be left with h squared.
No. I was saying 1 over 3 prime or h squared.
To the 1 over 3 pi h squared.
H squared.
So this is the derivative. Now let's replace h by 9.
Okay.
Replacing h by 9. So 1 over 3 pi
9
squared is equal to your answer. The answer that they're looking for. Which is equal to 27 pi. Which equal to 27 pi, of which you can choose to round it off or to write it as a decimal. But even if you leave it like this, you still get your full marks. So the final answer is 27 pi.
So how do we get a pi here on a pi sign on the calculator?
Let me check. I don't have a calculator with me.
Okay.
But I want to check from the picture that you sent me. There's a picture that you sent me.
Okay. Oh, I do see.
Okay. It's 10. You
Yeah.
press shift and 10 and then yeah.
Okay. One
Okay.
over 3. Let me try it.
Okay.
Yeah. That's fine. We can continue. Let us see.
What?
I said it's fine. We can continue. This calculator.
You should throw it.
Yeah.
Because You'll be writing soon.
Yes. I'll try to check that manual. If it doesn't change, I will throw it.
Yeah. So do you have another one? Like,
I don't. It means I have to buy another one. If it doesn't do, or borrow from someone.
so now we can move to the question. You can see that we are close to finishing this thing.
Yes.
Yeah. Let's move to this question. They're saying a blue and green bucket are filled with balls. The blue bucket contains 5 white and 3 red balls. The green bucket contains 2 white and 7 red balls. A bucket is randomly selected and 1 ball is thereafter randomly drawn from the bucket. That is the statement that we are given. So, first step, they're saying to you, draw a tree diagram. Draw a tree diagram to represent the information, clearly indicate the probability of each branch of the tree, show all possible outcomes. So let's draw a tree diagram. I'm going to draw a tree diagram. So I'm still trying to open something where I will be able to draw this diagram.
Okay.
Okay. Okay. I don't know what's it. Oh, here it is. This is how the tree diagram looks like. This is how your tree diagram looks like. So we're having a blue, let's say a blue and green bucket are filled with balls, meaning that the first diagram will be for blue and green. The first, this one, will be for blue and green. This one is for blue. We have for green here. So it continues to say the blue bucket contains 5 white balls and 3 red balls. So the blue bucket contains 5 white balls. Okay, meaning here we're going to have for the white balls, it contains 5 white balls and it contains 5 white balls and what? And 3 red balls. So 5 white balls and 3 red balls. So if you add 5 and 3, it gives you 8. So you will have 5 over 8. And then on the side, it's 3 over 8. And then here, because it's the probability for blue and green, of which you have only blue and green, it will be 1 over 2. It's either you will select blue or you will select green, which is 1 over 2. This 1 over 2, we carry it down. Carry it down. So another one says the green bucket contains 2 white balls and 7 red balls. So here on this other one, okay, Control V. For red, the bucket for red, and the bucket for white. And another bucket for red. So it says the green bucket contains 2 white balls and 3 red balls. So if you add 2 and 7, it gives you how much?
9.
It's 9. So it's 2 white balls and white balls. So it's 2 over 9 and 3 over 9. 2 over 9 and 7 over 9 because it's 2 white balls and 7 red balls.
7 red balls.
So that equals your tree diagram.
Okay.
They say draw a tree diagram looking at the information that we are given. You will draw it like that.
Okay.
Okay. Determine the probability that a red ball is drawn. Let's go to the question. Have you already drawn this thing or?
I haven't.
You haven't?
No.
Okay, let me just give you five minutes.
I just did a screenshot. It's fine.
Okay.
Thank you.
Okay, let's go to the next question. We are done with this question. So now let's go to the next question, which says determine the probability that a red ball is drawn. Determine the probability that the red ball is drawn. So let's insert the formula for determining the probability, which is P into R is equal to the probability of BR plus probability of GR. Which will be equal to you remember we have 1 over 2 and 3 over 8.
Yes.
Okay. Where's that tree diagram? So it's 1 over 2, 3 over 8.
3 over 8.
And then we have 1 over 2, 7 over 9. Okay. You're having 1 over
2.
1 over 2 times 3 over 8. These are the containers that these buckets, they are the ones that are containing a red ball. That's 1 over 2, and then the other one is 7 over 9. Using a calculator, or maybe let's first simplify, which equal to 1 times 3 is 3 and 2 times 8 it's 16. So we'll have 3 over 16 plus 7 over 18. 9 times 2 is 18. 7 over 18. Seven over 18. So this one will multiply this one will multiply this one, and then multiply equal to 3 times 18. 3 times 18, it's 54.
Okay.
And then plus 7 times 16, which is 112 all over. All over 16 times 18, which is 288. So 54 plus 112, it's 116, 166. So 166 over 288. 188. So 166 over 288. 166 over 288 is how much?
6 over
166 over 288.
Gives me 83 over 144.
144.
83.
83 over 144. That is the probability that a red ball will be drawn. We use 3 over 8 and 7 over 9 because if you can check a red ball, it's 7 over 9, like from the tree diagram. And then in the other one, it's 3 over 8.
Over 8.
And this side,
Is
it's always 1 over 2. The probability is always 1 over 2. Anyway, we also utilize these two guys.
okay.
So the probability that a red ball will be drawn, it's 83 over 144. We can go to the last question, which is only 2 questions. Okay, let me remove this graph here. And also this thing. It says Eastern Cape requires new codes for number plates. The new codes consist of letters followed by 4 digits. As shown below, all codes end with EC. BCD F3856 EC. The vowels R, A, E, O, U, and Q may not be used, and digits 1 to 9 are used. Letters and digits may be repeated. 1 to 9 are used. Letters and digits may be repeated. So the first question says, determine how many number plates with different codes can be made. Going to determine how many number plates with different codes can be made. So n codes is equal to, they're saying these letters cannot be used. Again, it's 1, 2, 3, 4, 5, 6, 6 letters. And how many letters of the alphabet do we have?
1, 2, 3.
From A to Z, we have, from A to Z, we have 26 letters, right?
Yes.
So in those 26 letters, we are going to subtract these 6 letters that may not be used.
Okay.
So if you say 26, subtract 6, you'll be left with 20. All right?
Yes.
So and letters and digits may be repeated. So it will be 20 to raise to the power 4 times 9. Why 9? 1 to 9 is 9. Raised to the power 4 multiplied by 9, which you also raise to the power 4 because digits may be repeated. So if you punch this one on a calculator, it will give you an answer. 20 to the power 4 multiplied by 9 to the power 4. Tell me if you get it.
20 to the power 4.
1, 2, 3, 4.
This is math error. This is not a calculator.
It says math error. Okay, this. I use a calculator on the phone. It gives me this answer. 20 to the power 4 times 9 to the power 4. Or you can simply leave your answer this way.
Okay.
Yeah.
Would be better, but I need to get a calculator.
So determine the probability that a code that is randomly selected, will consist of even digits which are not the same. Code that will be randomly selected will consist. The probability that a code that is randomly selected will consist of even digits which are not the same. So if we are dealing with codes which are not the same, we use what we call the factorial notation. Factorial notation, if you're having 4 factorial, it simply means 4 times 3 times 2 times 1. That's 4 factorial. Even on your calculator, if you say 4 factorial, it will give you the same answer you would get if you were to say 4 times 3 times 2 times 1. 4 factorial equal to is equal to 24. So it says determine the probability that a code that is randomly selected will consist of even digits of which are not the same. The reason why we raised this to the exponent 4 is because letters followed by 4 digits. So this 4 is from the digits that are to be followed. So we're going to say 4 factorial because now we want to determine the probability that a code that is randomly selected will consist of even digits which are not the same. So it's 4 digits that are to follow and multiplied by those 20 letters, raised to the exponent 4. So this 4 comes from this one. The statement says Eastern Cape requires new codes for number plates. The new codes consist of 4 letters. You see, we're having 4 letters. So 20 times 20 times 20 times 20 times 20, and then followed by 4 digits as shown below. All codes end with EC, and then it says, it continues to say 1 to 9 are used. Letters and digits may be repeated. So 1 to 9 they are used. That is why we're having 20 to the exponent 4, which is multiplying
by
the
9
9
exponent
digits
4.
to the exponent of the digits that may follow or that follows. So to determine the probability that a code that is randomly selected will consist of even digits which are not the same, we say 4 prime times 20 to the exponent 4, because these digits may not be used. They are out. So 26 minus 6 is 20. That is why we raise it to the exponent. And that is why we multiply by 20. And then in 4 is for the digits that are to be followed.
Okay.
So 4 prime times 20 to the power 4, it's 3,840,000. 3,840,000.
Okay.
Boitjela matshwao a gago.
Wow.
So I can say if you will be available tomorrow, or maybe on a load shedding ka nako mang moo?
The 5 o'clock.
Ka 5. Okay, this side yo ba ka 4 again. Yo ba ka 4. So 4 5 6, meaning ka 6 o ho. Wena ka re ke ka 5 ke 5 6 7. So maybe at 7 we can try to treat paper 2.
Okay.
On a yona that question paper.
I don't have.
Okay, firstly, or maybe we'll do it tomorrow. Ereko sendele yona ke treat it, and then we'll do it together. The
Okay.
next time, Ruthakan.
Okay. Thank you so much.
You're welcome. Let me stop recording.